Today we will solve the problem 2.25 of Griffith 4th edition Introduction to Electrodynamics. The problem 2.25 is find the potential at a distance z above the center of charge distribution as shown in the figure. There are three configurations are given. In each case, compute E, which is equal to gradient of V. Suppose that we change the right hand charge in the figure A from plus 2 to minus q, plus q to minus q, then what will happen? What then the potential at Pi? What field does it that so now three configuration were given. One is due to point charge. The second and third is due to charge distribution. This is the line of charge. Charge is distributed over a straight line. Here is a surface charge. Charge is distributed over a circle. Then we will find each case one by one. First, you take the case of point charge. There are two point charge kept at the equidistance from the origin. That is from here. The total length between two charges q t. So distance between each charge is equal to t by 2. Here t by 2. Here another t by 2. Now we have to find the potential. Potential by definition it's equal to 1 over 4 pi epsilon naught summation over I equal to 1 to n qi over ri r. If it is the uniform charge distribution, this summation will be changed to integral. That you know very well. Because it's a point charge, we are using summation. Here, luckily, we got the same charge and the same distance. Let us say we are considering a point Z here. Then, what is the distance between this charge and this point Z over P? This is equal to this point is Z. Uh, this is uh, this is R, distance R. We need to know R. So Qi here Qi two times we have to add plus Q 2Q you will get. Then R is equal to square root of T over 2 uh, whole square plus Z square. That is T squared over 4 plus Z squared R cat. Sorry, this is Z cat. The electric field is equal to negative gradient of potential. Now you take this potential and take out all constant. That is minus, here it is minus 2q over 4 pi epsilon naught. You take partial derivative with respect to z. So now I am writing here only one variable, that is square root of t squared over 4 plus z squared. So I am writing this as power square root as minus power of, because it is in the denominator. Now if you differentiate this, you will get minus of, then you have to subtract 1 from here. Then this will become 3 by 2, power 3 by 2. And if you differentiate this, if you differentiate first term, it will become 0. If you differentiate z squared, you will get 2z. So now here 2 will get cancelled. Sorry, 2 will get cancelled. So similarly, this minus and minus will get cancelled, will become plus. So this will be, here you have z, 2qz over 4 pi epsilon naught. This will this can be written as 1 over t squared over 4 plus z squared whole thing power 3 by 2. I am bringing this to the denominator. Then the question asked is, another question asked is, what will happen if this one side q is replaced by minus q. This is replaced by minus q. Earlier case, when both charges are equal, then the field due to this plus charge, this positive charge, and the field due to this negative charge, sorry, positive charge, is in along this direction. Uh, so the electric field or potential cancel, parallel line cancel each other because both are equal charge. Now, what will happen if it is minus q? Previous case, one the parallel component exists, but in this case, parallel component also get cancelled. So because one side is plus q, other side is minus q, both are symmetrical, one kept at equal distance. So the potential will be equal to 0. Uh, However, what about the electric field? Electric field, we don't we know the idea about z direction. We don't know anything about the x direction or y direction. So naturally, we cannot. We need to know the x and y direction electric field. So as such, the electric field is equal to, sorry, potential is 0. So the electric field also will be equal to 0 now. So electric field, which is equal to negative gradient of potential, is also equal to 0. Then we will move on to next safe. Then the next case is we are taking uniform line charge. Now you consider a small portion Tx, small area, infinitesimally small. So this uh, thickness is Tx. Similarly, exactly is symmetrical one I am taking, because symmetrical one that yeah, that is a perpendicular component will cancel out. So only we have to concentrate on parallel component that is parallel to z axis. That you have to remember. Perpendicularly, I mean perpendicular to z axis. Now you uh, consider a distance r at the point z. This point is z. What about this? Total length is 2l. This I am taking as x. So x maximum value is L. Here we have 1L, here this side 1L. So you will get 2L. Then what about this distance R? This R is equal to x squared plus z squared. That's what I am using here. Now I have replaced summation to integration. So 1 over 4 pi epsilon naught integral between minus L. This is minus L and plus L. Between minus L to plus L, the charge at the distance Tx is lambda multiplied by, here the line of charge is lambda. So lambda dx divided by r. Here r is equal to x squared plus z squared. So square root of x squared plus z squared. So you take the lambda out because it's a constant. So you will get this. This is very standard integration. You can easily prove it. Is integral value is ln natural logarithm of x plus square root of z squared plus x squared between the limit minus L to plus L. So if you apply the limit, if you first you apply the upper limit x equal to L squared, this will become L squared, this will become L minus this lower limit is minus L. So this x will become minus L. Then plus a square root of z squared x squared. Though it is negative, when you square it, it will become simply L squared. Now this can be written as natural logarithm of this. This comes in the numerator, and this one comes into the denominator. Uh, to find the electric field, we are going to take this equation. This equation we are going to take. So we will see further how to find the electric field. For mathematical convenient, we have taken this lambda over 4 pi epsilon naught natural logarithm of L plus z squared square root of z squared plus L squared minus L minus natural logarithm of minus L plus square root of z squared plus L squared. Of course, you can write this term in the numerator and this one in the denominator in common natural logarithm. I am doing this because of some mathematical convenience. So now I am going to write this second part, the square root of z squared plus L squared as z squared plus L squared power half. Here also I am doing same thing. Now, if you differentiate the natural logarithm of x, you will get 1 over x. So that was I have taken 1 over this term, uh, square root of z squared plus L squared plus L, this L. And again you differentiate because here it contains z squared, so you differentiate with respect to x. This is plus half, so this will become half half 1 over 2 half, then this power will become, if you reduce minus 1, half minus 1 is minus half. So I am taking this term to the denominator. Then you differentiate the z squared. Z squared, if you differentiate, you will get 2z. Here 2z will get cancelled. 2 and 2 will get cancelled. You do the same thing here. If you take this logarithm and differentiate this natural logarithm, you will get 1 over shape. And here also you do the same thing, and then here this 2 will get cancelled. Now you can see you have z here, z here. You take the z as common in this here. Also, not only z, this term 1 over square root of uh, this entire thing you take outside. I will use different color maybe. So this z divided by square root of z squared plus L squared. So here also you take this as common. So lambda z 1 over, of course there is a negative sign, 1 over square root of z squared plus L squared. Now remaining thing is 1 over square root of z squared plus L squared plus L minus 1 over z squared plus L squared minus L. Now what I am going to do is this entire thing in the square root I am going to take as A. Let we take L as P. Here it is A again, and this is P. L is P. So this will become in the denominator A plus P into A minus P, which is equal to A squared plus minus P squared. If you multiply this, you will get a squared minus b squared. Here, a squared is square root of z squared plus L squared. So this will become z squared. Square root will get removed. Z squared plus L squared. And if you take minus b squared, here b is L. So minus L squared you will get. Now you have taken both the term as a common. Now this term in the denominator will go to numerator here. That is square root of z squared plus L squared minus L. Then here this term will go. That is minus square root of z squared plus L squared. So here you have plus L. Already there is one minus. This will become minus L. Now the square root term will get cancelled. The square root term will get cancelled. And remaining thing, we will see this minus L will become minus 2L. We will see it. So, as I said, this square root term and this square root term in the denominator will get cancelled. That means this and minus of this same thing will get cancelled. So you will get in the numerator minus 2L, simply minus 2L. You will get minus 2L in the numerator. Then here this L squared plus L squared will cancel with this minus L squared. So in the denominator you will get only Z squared. So in the numerator you have minus 2L, in the denominator Z squared. Here this Z squared will get cancelled with this Z. This will become simply Z. So you bring and also this minus of minus is plus. So you will get 2L lambda over 4 pi epsilon naught multiplied by 1. Remember that there is Z here. Z square root of Z squared plus L square. This is exactly what we got in the example 2.2 of Griffith. Example 2.2 of the Griffith. Then we will move to the next shape. So we have seen the line of charge. Now we will see the surface charge. Let us take this circle. You take a particular point at a distance small r uh, from the origin. This radius is capital R. You remember that. Now you find the potential due to this point is a small point from here to the point Z. So this is Z. Remember that this is Z. So what is this distance? Let us say this distance is script R. Script r, then this distance is equal to r squared plus z squared, square root of z squared plus r squared. This square root. So this is the distance between the small area under consideration to the z-axis. Now the charge is equal to sigma multiplied by 2 pi r. 2 pi r is the area of this small area under consideration at r. This you can form a circle around this. So that is 2 pi r. Tr divided by square root of z squared plus r squared. Now you can take constant out. Before that, we can cancel this 2 pi and 4 pi will become just simply 2. So this can be written as sigma over 2 epsilon naught integral between 0 to r r divided by square root of z squared plus r squared. Now you replace this z squared by change the variable z squared plus r squared as u. So u is equal to z squared plus r squared. Then du is equal to, if you differentiate this with respect to r, it will be 0. Then this will be 2r dr. You bring 2 to the left hand side. Then it will become du over 2, which is equal to r dr. Now you replace r dr by 1 over 2 du. 1 over 2 du. This I am replacing this RTR. So RTR is replaced by 1 over 2 du. Then this is replaced by square root of u. So this can be written as half u power minus half. Then if you integrate u power minus half, you have to add plus 1 naturally. Then if you add plus 1, this will become u power plus half and divided by half. So this half and half will get cancelled. So only u power half between the limit to 0 to r. So u power half is this one. U is equal to z squared plus r squared. So this can be written as a square root of z squared plus r squared between the limit to 0 to r. So when you apply substitute r, this will become z squared plus capital R squared. And if you lower limit is 0, if you replace r small r to 0, then you will get square root of z squared, which is simply z. So this is the potential. Hereafter, you remember that the integral over r uh, divided by some constant, maybe a squared plus r squared. The integral is simply equal to square root of course, dr, square root of a squared plus r squared. This is the standard integration. I'm going to use frequently. I'm going to use this frequently. So you remember that. This is also another standard integration. So here I have done by replacing the variable. So hereafter I will take it as granted. If you integrate r over a squared plus r squared dr, you will get to square root of a squared plus r squared. So our potential is equal to sigma over 2 epsilon naught square root of z squared plus r squared minus z. Now we will find the electric field. So now we have to calculate the electric field. We know the potential. Potential is this one. So the electric field is negative gradient of the potential. So you take the constant out, that is minus h, because here there is minus sigma over 2 epsilon naught, the partial derivative of t by tz. This term you are going to differentiate because it's contained variable. So now I am going to rewrite this as I can replace this by this one. That is, I am writing this as a z squared plus r squared whole power half. Now, if you differentiate this, you will get that I will do it here for simplification. So we have to differentiate z squared plus capital R squared uh, half. So you bring this off here, then you will get z squared plus r squared of minus 1. So this of minus 1 will become minus of. So this will become minus of. And you are not supposed to forget z squared. If you differentiate this z squared, you will get 2z. This is 2z. So that's what I have written. 2z over 2. This 2. 1 over 2, 2z. 2z 1 over 2. Z squared plus r squared minus of. Here minus of. If you differentiate z with respect to z, you will get 1. So that this is minus 1. Here you can see this 2, 2 will get cancelled. Then here you have z. Here there is a minus. You multiply the terms inside the bracket using minus 1. Then this you bring this inside the bracket. This minus 1 become plus 1. Then this term is z divided by, because it's minus of whole power minus of, will become z over square root of z squared plus r squared. So this is what we got the result of problem 2.6. Exactly, we got this answer for problem 2.6. So this is also we have verified. Thank you very much for watching my videos and supporting me continuously. Thank you very much.